Welcome to another T-Rex Talk podcast episode. This is Isaac Botkin, and today we're talking about drones, drone development, drone uses, and kind of drones for the future a little bit, but this isn't going to be a super cutting-edge podcast because I'm not a drone developer. There's top-secret drone developers doing really cool stuff that we don't know about, so my projected drone usages are probably not going to be all that futuristic compared to stuff that's already being done in top-secret black Area 51 labs already. But I'm also going to be somewhat sloppy with the term drone because it's an extremely sloppy term. When we talk about drones, technically what we mean is unmanned aerial vehicles. They may be fixed wing, they may be rotary wing, they may be quadcopters, octocopters, they may be jet or rocket powered, but drone specifically means an unmanned aerial vehicle. But in the eyes of the media, drone means a quadcopter, and so oftentimes I see articles about new manned drones, and what they mean is a quadricopter that is big enough to carry a person. And actually, most of those are octocopters, but that's how the media works. They don't really get caught up on things like words or correct definitions, even though it's kind of literally their job. Now, quadricopters are pretty new for some reasons that I'll get to in a little bit, but drones, we've been using target drones in the U.S. military, well, since World War II, and there have been drones like the V-1 buzz bomb that the Germans were launching against London in World War II. So unmanned aerial vehicles, which is technically what drones are, have a pretty rich history in military uses. Been a lot of people using them for things like surveillance, signals intelligence, but in my lifetime, there's been an increased use of them actually being armed. And then the other thing is we see a lot of cruise missile use as well, and those are basically just explosive drones. There's not much difference between a Tomahawk cruise missile and a drone that carries Hellfire missiles, except which part of it's actually reusable. And that line is getting even blurrier now as you research stuff like loitering munitions, stuff that you can shoot up in the air and it actually uses tiny helicopter propellers to hold itself up there for 20, 30, 40 minutes while it waits for enemy vehicles to come along and then drops on them. And one of the proof of concepts here is there's a lot of people in other countries that are already doing this with off-the-shelf drones. Just a couple of days ago, the Iraqi prime minister claimed that he was the survivor of an explosive drone attack. Apparently, 3 drones came down and exploded very close to where he was. This isn't entirely confirmed yet. It's possible that this was just a distraction from all of the protesters of the government that are ending up dead in Iraq. But there are so many drone attacks, so many unmanned aerial vehicles being used for these types of purposes, being used for these types of irregular, asymmetric warfare, being used for long-range strikes. We're going to see more and more and more of this stuff. But there's a very rich history of military units from all kinds of different countries using drones, unmanned aerial vehicles, most of which have in the past been fixed-wing devices, using those for advanced recon or for spotting use, which is especially useful for indirect fire. So if you're shooting mortars or artillery, having a drone that you can throw up and see what is over the hill that you're shooting over is extremely important, and that's extremely common. But the recon capabilities of small UAVs has really come down quite a bit to lower and lower levels of the military. So now there are a lot of small man-portable, man-launched recon drones. Probably the most common in American use is the Raven, which has like a 4-foot wingspan, and you throw it, and hopefully it goes up and not nose first straight into the dirt. That is a pretty effective fixed-wing drone, and it goes all the way down to little teeny tiny drones, like the Black Hornet drone, which FLIR sells here in the United States. That's about 4 inches long, and it's a tiny helicopter with a visible light camera and a thermal camera on the nose of it. So it gets pretty small and pretty sophisticated, although it also comes at a cost. Apparently those things are well over $100,000 for something that is smaller than a $5 remote-controlled helicopter that you get from Amazon. There's also, and this is pretty interesting, 40mm launch drones, so the whole drone folds up and can be launched out of a 40mm grenade launcher so that you give it instantly a lot of altitude, and then it pops open once it's up there and can either be a surveillance drone with a camera or can be some of those loitering munition type drones that actually carry some kind of weaponized payload. And then the next step is going to be drone swarms. So the advantage to a drone swarm is you get a whole bunch of drones all working together in concert. So you throw up dozens of drones, some of which have weapons, some of which have advanced sensor packages. But because they are spread out in all of their intelligence gathering, computational power is spread out, and attack power is spread out so that they can really quickly be agile and also very hard to take down, because you can take down one or two of the drones without knocking out the entire swarm. I don't think that these things are going to have significant centralization, because all the people who are making drone swarms today have surely seen all the movies where there is one command ship and all you have to do is hit the command ship and then all the drones just fall out of the sky. So everyone has seen those movies. Everyone knows probably not to do that. And again, this is something that is being developed. I don't think anyone has fielded a autonomous drone swarm in this way before, even though there's a ton of research being done here. You will see swarms of drones doing things like light shows. This is being done in China. Intel has built very large swarms of drones that operate non-autonomously for the most part, doing pre-programmed light show stuff, but drone swarms would be more autonomous groups of drones working together as a team. But there's also a ton of advancement in the commercial space. So drones have just been incredibly valuable, and at this point they're almost entirely quadcopters. They've become incredibly valuable in the commercial space as well for things like structure inspection or site surveys, even warehouse inventory. So Amazon has these gigantic warehouses full of inventory, or rather, they were full of inventory. It is now the late stages of 2021. They may not have that much stock left in time for Black Friday and Christmas, but they have these huge warehouses. And one of the ways that they can inspect and keep up with inventory in warehouses is they have indoor drones that fly back and forth along the lines with barcode scanners. And actually, that is a phenomenal use case for this aerial platform. Something that is precise enough and agile enough to do that is incredible. It's so much more cost-effective than, say, a wheeled robot with a mast that has to go up and extend 40 feet up to read the barcodes of stuff that's on the top of a 40-foot shelf. All kinds of fascinating automation opportunities open up when you have something like a quadcopter that is extremely controllable and extremely cost-effective in a lot of ways. And then another really good application for drones would be farming and mapping, stuff that used to be done predominantly with manned aircraft, but smaller unmanned aircraft can be cheaper. And a lot of these actually are not quadcopters. A lot of farmers are doing stuff with fixed-wing aircraft because you're looking at large spaces. And if you have a drone that has a multispectral camera on it, something that can see infrared light, visible light, and thermal, you can actually do a really good job of keeping track of which parts of your crop are doing well, which parts of your field need more fertilizer, more water, more whatever. So they're getting increasingly used in farming and mapping applications. But there's also the recreational side, which is probably what you are more familiar with. The cinematography drones that carry little cameras. Some of those are just for goofing off. Some of those are actually being used in fairly significant films. When I say significant, of course, I mean money, not necessarily like great cultural value. So I was talking to a guy who was a drone pilot on one. I probably shouldn't say the movie, but it was a very large movie, and they toasted a drone while flying through a ginormous truck explosion. And that's the sort of thing that is great for drones when it's too expensive or too dangerous for a helicopter pilot. And this is a phenomenal field. Both cinematography and then FPV drone racing and stuff like that has really opened up the recreational side of this in a huge way, and very, very recently. So when I was a kid, brace yourself, this is another one of those when I was a kid stories. I really wanted to get into remote-controlled airplanes and remote-controlled helicopters. I thought that would just be the coolest thing ever. But the complexity and the cost of those things back then was really, really high. Most remote-controlled vehicles at that time actually used tiny gas-powered engines. So they had these little glow plug engines, and they had these very smelly and difficult chemical concoctions of nitro fuels that would run them. And they had analog radios that had all these little tiny control surfaces with linkages to the servos. It was just a really time-consuming and expensive and complicated thing to be a part of, and I couldn't afford it, and also my mom was not super excited about having those nitro fuels lying around the house while I built these little teeny tiny, impossibly complex remote-controlled helicopter pieces. And then there's also the safety aspect of flying a remote-controlled helicopter with a 4-foot rotor around outside where all of my younger siblings are playing. So I never actually got into that as a hobby as much as I wanted to. But a number of changes happened that completely flipped the cost and complexity of this as a hobby on its head. So lithium-ion batteries and brushless motors made electrical power something that was feasible for this, way better than gas-powered motors. And then digital communications made the radio side of things way better than those finicky old FM Futaba radios with the crystals. And the quadcopter itself was made possible by computational power inside of a really small package. So the way that a quadcopter works is you're balancing the thrust or the lift of 4 different propellers, and you have to make hundreds or sometimes even thousands of little throttle corrections every second in order to keep those things flat and level. That's something that wasn't possible with the microprocessor technology of my youth, but that thing is like pennies to do today. You can easily put an entire quadcopter on a single printed circuit board these days. The central processor that does all that flight correction, the solid-state gyros and accelerometers, all of the voltage stuff, the digital radio. You can even print the antennas for the digital radio directly on the circuit board. And then the only thing that you have to do is connect up the battery and the 4 motors, and the propellers are driven by the 4 motors directly. There's no linkages, there's no transmission, it's just direct drive. It is phenomenally simple at a hardware level, and you get a significant amount of stability and agility out of that platform that you didn't have with the old remote-controlled airplanes and helicopters when I was a kid. So the ability for people to just pick up this hobby relatively cheaply, and it's easier to do as well, relatively much easier to do, that really has changed the game completely from a hobby perspective, but also significantly from a actual usefulness perspective, especially as the years have gone by and things like cell phones have really pushed the envelope when it comes to miniaturization of technology, particularly of cameras. Now you have a really small, lightweight, fairly robust, easy and cheap to manufacture device carrying around a 4K camera that's the size of your thumbnail and shooting surprisingly good video on a gimbal that stabilizes it and is controlled by a computer that is remarkably intelligent for the few pennies that it costs to solder onto the board. So that's where we are today. Obviously, there are different types of aerial platforms, like fixed-wing devices are far more useful for a long-term flying solution. You can get a couple of hours out of the same battery that holds a quadcopter up for 20 or 30 minutes. But there's a level of complexity that is there. Those things are harder for an autopilot to fly. In some ways, they're definitely harder to build. Quadcopter is very simple, and there's tons of flight models for those, and you have all sorts of existing off-the-shelf parts that have been developed for those, and you have the ability to hover. You have the ability to fly those things with a level of precision where, like Amazon, you can just be indoors, fly them around inside a giant warehouse and get barcodes off of shelves really quickly and easily and precisely. So that's really where I see a lot of existing development sitting for a while, and that's where I see a lot of tremendous use for the future. Obviously, there are tricopters, and there are hexacopters, and there are octocopters. But where we are in the commercial drone space right now, if you didn't know this already, DJI is the market leader. So the Mavic, formerly the Phantom, they have a whole bunch of different drones, different capabilities and price ranges, and more importantly, different weights, so that certain drones fall below the FAA weight requirement for registration, and they are, without a doubt, the market leader in the United States. They make the best drones, the most sophisticated drones. They're not the cheapest drones. They are a premium product, but they are an extremely successful premium product, great name recognition, and I mean, they do really make very solid products, with some downsides that I'll get to in a second, but they are the market leader, and they're the market leader in a market that is relatively difficult to break into if you want to be the next DJI. And that was demonstrated by GoPro. A few years ago, GoPro tried to break into the drone market, which was kind of a no-brainer for them. They had an action camera. What could be better than a gimbal for their action camera or a flying gimbal? So they developed something called the GoPro Karma. It was supposed to be an incredibly sophisticated next-level drone. And to be honest, they did a not terrible job of building a drone from scratch without having any prior experience with it. The problem was they released their first try, and it didn't go well. In fact, it went so poorly that they never worked on a second try, or at least never released the second try. So this is relatively difficult to do at an extremely high, polished production, turnkey, anybody can fly it, works every time, smooth and sleek enough to sell inside of Apple stores kind of way. DJI kind of has a lock on that particular space. However, there are some downsides. DJI is a Chinese company, and a lot of the sophistication in their devices requires that they send all of your data back to China at very regular intervals. At least that's what we're told. We're told that in order to have this kind of sophisticated product, they need to look over your shoulder and have your telemetry and your cameras and stuff like that, which is why U.S. military officials and most law enforcement people are not allowed to use DJI drones for stuff because of the security implications. And there's also some other difficulties. Even if you don't care that the Chinese government is seeing where you fly your drone, you still have to connect to their servers to download updates and prove that you are in the right spot and not flying next to an airport, and et cetera, et cetera, et cetera. There are ways around most of these restrictions, but they really want to make these drones as safe as possible, which I approve of, but they also want to make these drones as compliant as possible with FAA and FCC and FTC regulations. And so oftentimes DJI will go above and beyond what the restrictions are so that they can be ready for the next level of restrictions that are coming. And in doing so, they inadvertently sort of lay the groundwork for what the next level of restrictions are. So one of the things that they have recently added to all their big drones is ADS transponders so that they are able to see and broadcast their location to light aircraft and large aircraft in the same way that other aircraft does to air traffic controllers. I think that's kind of cool, but it's also the sort of thing that now they sort of taken that step, and that's going to be the sort of thing that the FAA requires for all drones of a certain size going forward in the future. So thanks for that to DJI. It's a mixed bag because their software support is really good. Their SDK is really good. There is an ATAC plugin, which works with civilian ATAC, where you can actually control and see your drone feed inside of ATAC. That's really very cool. But at the same time, having to ask for all these permissions and jump through all of these hoops and have all of these safety features in place is really a pain. And again, the whole thing is being made in China and designed in China, and it really wants to phone home and talk to China all the time. So there are a couple of other options for you if you would like a product that doesn't do that. One of my favorite drone companies is Parrot. They're a French company, and they have a little tiny drone called the Anafi. And it's not super sophisticated. It's now, I think, a 2 or 3 year old drone. It's about $500, and it doesn't have the safety features that the DJI does. It doesn't have to talk to their servers. It doesn't have to look for updates. It can just fly. It doesn't really matter. However, there is a downside to that. It doesn't have any of those safety features like obstacle avoidance either. So I have gotten it stuck in trees a couple of times where a DJI drone would have automatically stopped. There's a Parrot Anafi that has thermal, which is about $2,500. And then there are the made in USA sort of enterprise level devices that they're working on now. Parrot used to be a hobbyist company making stuff for the hobby area, but now they're leaning a little bit more commercial, getting into more expensive and more capable drones, but not a ton more expensive. Like, they're very price competitive with other people in the recreational space. And they're adding features that I like. For example, one of the latest features that they have is encryption, so that if you lose your drone, all of the footage that's been recorded onto the SD card and all the telemetry and stuff is all encrypted. So if somebody intercepts your drone, they can't actually see the footage on there or the telemetry or any information. That's a super cool feature that I'm not seeing anybody else talk about, certainly not DJI. There's another made in USA drone called the Skydio. This one is completely automatic. It's actually very hard to fly manually. The Skydio is a full AI drone that basically follows you and avoids obstacles, and some of their demo videos are impressive. The drone is following downhill mountain bikers through the forest, dodging trees and branches along the way, and that's a $1,000 drone all made in the United States. So there are starting to be more options that are available to you that are local and have slightly better capabilities and have slightly less problematic security issues. So I think this is a really important area to look at in the future. I think that it's going to get better and easier for anyone wanting to experiment in the drone space. And of course, there's also home-built drones. When you home build your own drone, you have the capability to control exactly what modules you're putting in there and exactly what features you're getting out. But obviously that's not for everybody. And then there are the larger commercial names like Skyfish or Dragonfly. They make commercial drones, enterprise drones, a little bit more expensive. They tend to make those here in the United States as well. There's Instant Eye. And of course, there's General Atomics, I mentioned, because they make the Reaper and Predator drones that you may have seen in various places. They also have the coolest name ever, General Atomics. But in many ways, they're not a drone manufacturer. They are an airplane manufacturer. They just happen to make airplanes that don't have a seat for the pilot. And I think there's a huge amount of value. This is a whole other podcast. There's a huge amount of value in unmanned aircraft for a whole bunch of reasons. But let's get back and focus on the little tiny man-portable, man-launched quadcopter kind of drones. Those have tremendous value. They have tremendous value for infantry units on the ground. They have tremendous value for just random guys like myself who want to be able to put a camera up in the sky, either because they're making a YouTube video or because they want to see roof damage or because they want to see what's on the other side of the next hill without hiking over there. There's a huge amount of value for this capability. And I think there's a lot of things that are pretty easily added to existing drone technology that someone just needs to pick up. We need to have some locally made, American-made drones that are a little bit more robust, a little bit more weatherproof, and there's a bunch of extra stuff that these drones could be doing. For example, if you were a sniper or a hunter and you had a small drone that you could send out and give you a weather report, not just where you are, but along kind of the area where you're going to shoot, that would be really easy and really helpful. Radio repeaters on drones are tremendous. If you're operating in an area doing some search and rescue stuff or something else and you don't have time to build a 200-foot radio tower, sending a drone up 200 feet is really easy. And it gets even easier if we have like a digital mesh network radio. If we have something like Meshtastic, sending one of those radios up can be done with even a tiny, tiny drone. Infrared floodlights are the sort of thing that would be super cool to have if you were doing stuff with night vision. It would allow you to throw up light that covers a large area and specifically covers the area where you want it to be, and it's not illuminating the area where you don't want it to be, and the light is coming from someplace that you aren't. That's a really cool thing that I haven't seen anyone do yet. Thermal cameras, very useful, very valuable. Obviously, lots of people do that. Multispectral cameras, very useful for finding out which part of your field is doing well crop-wise, which part of your field has weeds in it crop-wise, which part of your field has camouflaged enemy units in it crop-wise. And then the signal intelligence capability of drones is pretty significant. Getting your drone up in the air not only makes it a very effective repeater for radios, but it makes it a very effective receiver for other radio signals. So setting a drone up or a couple of drones or having some kind of direction finding capability hanging from the bottom of a drone, you could gather a huge amount of the RF spectrum and do a lot with it. You could use your SDRs for data collection. You could see what other signals are out there, what other communications are happening. And then, of course, you could also put signal jammers on a drone, especially a drone that is a little bit more autonomous. Which brings me to counter-drone technology. The easiest way for drones to be countered is with jamming. Remotely controlled drones are relying on these radio signals that you can easily jam if you just have a big enough and powerful enough jammer. And that usually confuses the drone, but it doesn't necessarily force the drone to do much. Sometimes it forces the drone to return home. So a more sophisticated way is by actually hijacking the signal. There are companies that are working with DJI and other countries to build a product which will only be sold to military and law enforcement, of course. And it has the ability to actually hijack that signal and control that drone and force it to land. So that will work really well against the commercial drones that work with these anti-drone companies. And the next counter-drone technology is probably just using a huge amount of microwave energy to not just jam the signal, but actually fry the delicate internal electrical components of the drone. Now, drones are small and fast, but if you have a phased array antenna, that signal is going to be aimed at a drone really, really easily. So that is a pretty sophisticated but very effective anti-drone technology. And then, of course, beyond that, there is always kinetic intercept. If you have the ability to shoot stuff down with bullets that is in the air, you can probably hit small, fast drones. There are anti-air capabilities that the United States military has capable of knocking out incoming mortar fire. They could definitely hit a small drone with a whole bunch of chain gun fire, and that would definitely be something that the tiny drone doesn't survive. But there's cheaper and simpler options for that as well, like birdshot. Actually, that reminds me of something that I didn't even think about until now, and that is, in the 70s, there was a project called SPEW. I forget exactly what it stood for, but it was a flechette testing idea. It was something that was being worked on around the time of the Vietnam War. There was an idea that perhaps we could get better capability from our weapons if instead of firing single metal bullets, we fired tiny, incredibly fast flechettes. And there was a significant research project that looked into this. And what they discovered was, unsurprisingly, that tiny, lightweight flechette rounds are not great when you're in a jungle war in the middle of Southeast Asia. But maybe if you're shooting down aerial targets, flechette rounds are superior to round, non-aerodynamic birdshot. So possibly it's time to bring back some of the experiments from the SPEW project with little tiny aerial targets instead of human targets hiding behind dense vegetation. And then more on the pro drone side, something that is extremely cool, and I don't see a whole lot of people experimenting with quite yet, is tethered drones. If you don't need an aerial platform that goes out and scouts for you, you just need something that's in a single place. A tethered drone is actually extremely cool because you can run that thing up on a long wire, and it can sit there for hours. So the DJI Mavic battery is about 4,000 milliamps per hour, and that can hold that drone up in the air for about 30 minutes. Your $100 O'Reilly's car battery is about 10 times the capacity because it's a pretty lame battery technology, but that's enough to hold that drone up there for 5 hours. And if you're able to control the drone over the wire, so there's no radio signals, there's no RF whatsoever, it's very hard for that drone to be detected using regular signal analytics, and it's very hard to jam that drone. So tethered drones are a very cool thing for people who want to do more stationary security or want to do long-term radio repeater type stuff. Putting a tethered drone up over a disaster site that you know that you're going to be working for several hours and need eyes on and radio repeaters on would be tremendously useful. And so I think that we're only just really scratching the surface with some of the stuff that drones can do. And I'm not even getting into the weird, crazy drone swarm stuff. I'm just talking about stuff that is relatively simple. Buying off-the-shelf thermal cameras, off-the-shelf IR LEDs, off-the-shelf radio repeaters, and running all these stuff with drones that are tweaked a little bit so that they're a little bit more robust or a little bit more efficient or a little bit more weatherproof. That is easily within the realm of possibility for a lot of people who are not gigantic three-letter agencies or DARPA. I don't think it's just because I used to want to get into remote-controlled helicopters when I was a kid. I think these are genuine game changers for the average guy. They certainly have been changing the way that regular soldiers have been doing warfare, both at a super high level and also down to individual infantrymen. And they've certainly changed the way that companies have been doing work, and they've changed the way that giant agriculture has been done. So they have tremendous capability to trickle down and change the way that we do things at a lower level and provide capabilities that previously have been out of reach. So continue to research this topic and continue to look into the little tiny quadcopter and drone space. Obviously, the drone wars have been going on for some time. But let's pay attention to the little skirmishes that are happening around the drone wars because I think they matter. I think that they are really important for us to follow so that we can continue to think about ways that we might want to be using quadcopters, recreational quadcopters for useful stuff like advanced intelligence or keeping an eye on your perimeter or setting up radio repeaters so that you can talk to people who need to be talked to. So thanks for listening, and I hope you learned a little bit from this extremely general overview of the drone industry in general and specifically the more affordable recreational side of things, because I think there's a lot of potential use that we could get out of that, a lot of value that is there.